Okay, so now that we have our reflection amount and our Fresnel calculations in place, in this video we need to deal with how we can combine those together into our final diffuse reflections balance pass. And earlier on the whiteboard we talked about the idea of multiplying our Fresnel with our reflection amount to give us that final pass, but in doing so we'd have our Fresnel calculations having 100% influence over our reflection amount. That means that if our Fresnel calculations gave us 100% reflections, then we get 100% of our reflection amount output. But if it gave us 0% reflections, no matter what our reflection amount was doing, we'd get 0% reflections output. And we don't necessarily want our Fresnel to always have 100% influence, because there are certain materials that really aren't that heavily affected by Fresnel calculations. So we came up with the idea that we need to somehow have a Fresnel influence where when we have a value of 0, Fresnel has no impact whatsoever, and as we blend up to a value of 1, Fresnel has full impact. Well, let's think about how Fresnel is impacting our reflection amount. When our Fresnel calculation comes back with a value of 1, we multiply 1 by our reflection amount and we have absolutely no influence. It's only when Fresnel comes back lower than 1 that we start influencing our reflection amount, because we're multiplying it by a value less than 1, thus we're decreasing its value all the way to when Fresnel comes back with a value of 0 and we multiply by 0, we're completely countering whatever value is in our reflection amount and we're always outputting 0. So with our Fresnel influence, when we want to have no influence, we have a Fresnel influence of 0. What we really want to be multiplying by our reflection amount is a value of 1, because that's going to have no influence over our reflection amount whatsoever. However, as we start increasing our Fresnel influence towards 1, we want to be multiplying by more and more and more of our Fresnel calculations. So what we can do, we can use this Fresnel influence to blend between a value of 1 and a value of Kr. As we go between 0, meaning no influence, we have 1 output. As we move up to 1, we output Kr, which is full influence, and in between we're blending back and forth. Now this Fresnel influence could just be a constant 0 to 1 value, but it would also be useful to specify this as a texture as well. So we'll deal with that first. We'll get that set up so that we have either a constant value or a texture driving our Fresnel influence. We'll then use that to blend between a value of 1 and a value of our Fresnel calculations. We'll take the result of that blending, multiply it by our reflection amount, and output that as our final diffuse reflections balance pass. So let's jump over into Houdini, over into our shader, and let's start out by setting up the network that's going to allow us to blend between either a constant value or the luminance of an image. And we really have that network already in place with our reflection amount. So let's grab our reflection amount map, the texture, the luminance. I'm not worried about the scaling, so I'm ignoring the scaling. The reflection amount, the amount toggle, and the switch. If we copy these and paste underneath, fantastic. The first thing you'll notice is that because we didn't copy all the nodes, the old multiplier is wired into input 2, so let's replace that with our new copy of the luminance. I now want to go through, and instead of having these named as reflection amount, I want to name them Fresnel influence. So Fresnel influence map, Fresnel influence texture, Fresnel influence, Fresnel influence map toggle, and switch Fresnel influence map. We need to make sure that any parameters have their parameter name and label updated accordingly. So Fresnel influence map toggle, and I'll leave that as use texture, and Fresnel influence. And we can set this to Fresnel influence. Fantastic. So the output of this network is going to be a 0 to 1 value, either driven by a constant value or by a texture. And we need to use this to blend between a value of 1 and a value of Kr coming from our Fresnel calculations. To do this, we're going to use a mix fop. So I'm going to create a mix fop. I'm going to name this to Fresnel influence blend, and our mix fop is very useful. It takes in two inputs, and based on a bias, it's going to blend back and forth between those two inputs. A bias of 0 gives us 100% of input 1, a bias of 1 gives us 100% of input 2, and as we move between, so a value of 0.5, it's going to blend between these two, so it's going to give us, in this case, 50% of input 1 and 50% of input 2. And we said when we had a bias, or rather a influence of 0, because we are going to be driving our bias with our influence, we wanted to output a value of 1. But when we had an influence of 1, we wanted to be outputting our Fresnel calculation. So there's our KR, our Fresnel calculation, and we're going to use that as input 2. So as we have a value of 0, we output 1. As we move towards 1, we output more and more of our Fresnel calculations. Of course, it's our Fresnel influence that's driving that bias. We take the output of this and we want to multiply it with the reflection amount that we're getting. So here's our switch reflection amount. I'm going to wire that into a new multiply, which we can name to multiply Fresnel. We can take our Fresnel influence blend output and wire that into the second input of our multiply Fresnel and take the output of that as our pass, because now we're taking our reflection amount and we're multiplying it by the Fresnel influence controlled Fresnel calculations. So all that's left to do is to promote up all of these new parameters to our asset, tweak those parameters and see how that is influencing our shader. So it's really, really simple network wise. And it's pretty simple conceptually. All we're doing is blending between a value of 1 and a value of our Fresnel calculation, multiplying that in by a reflection amount, and that gives us the final value that we're sending to our pass. So let's bring up the parameters for our material. And I want to, into the reflections folder, from our material, I want to promote the Fresnel influence map, and also the use texture toggle. So I'll promote those up. And I want to move these beneath our index of refraction. And I want these to be ordered such that our Fresnel influence, just the value is first, then the toggle is second, and then the map is third. And just as we've done before, let's deactivate the value and the map based on our toggle. So when the toggle is turned on, we want to deactivate the value. So disable when our toggle is equal to a value of 1. And when the toggle is turned off, we want to disable our map. If we accept this, bring up the parameters, we can now see here are our parameters, index of refraction, then we have our Fresnel influence as a value or as a map, toggling back and forth. So let's start out with a Fresnel influence of 0 and let's render our pass. So I'm going to hunt down our output. There's mantra 1. Notice we are still set to the diffuse reflection balance. I'm going to render that. And while that's rendering, let's bring back our network editor. Let's look at our composite view and jump over into our network. So hopefully by now mantra has finished rendering. Indeed it has. And if we now look at our pass, what we're seeing is pure red, because in our red we're getting 100%. Why are we getting 100%? That's because we have no influence of Fresnel, and we have a reflection amount of a constant of 1. So we're getting 100% of our reflections, and the end result is that we're getting 100% of our reflections. If we look at our reflection pass, it's identical to what we're getting out of our blend. So let's now increase our Fresnel influence. I'm going to increase this first to a value of 1. So now we're using 100% of our Fresnel. No matter what our reflection amount is doing, it's always being affected by those Fresnel calculations. So that means that our Fresnel, where we have glancing angles giving us a strong amount of reflections, is going to be multiplied by a value of 1, giving us those strong reflections. But at facing very straight on angles as opposed to glancing angles, we're going to get a very low, if not 0, Fresnel calculation. And even though that's multiplied by a value of 1, it's still going to give us no reflection. So we should be able to jump back over to our output context, render, let's just wait for mantra to render. There we go. So now we should see something exactly like we were seeing when we were dealing with our Fresnel pass without having reflection in terms of reflection amount taking effect, because we're just getting the Fresnel, and that's because we're multiplying it by a reflection amount of 1. So reflection amount in this case is having absolutely no effect, and the result is something that looks kind of plasticky, as we were discussing earlier. But now we could decrease the reflection amount if we wanted, so no matter what the Fresnel's doing, when we have full reflections from the Fresnel, that's only ever 0.5 reflections. When we have no reflections from the Fresnel, then that's going to be 0 reflections. So let's go ahead and render that. So there's mantra. Fantastic. So now we should see something like this, but our highest values are now all going to be decreased because we're only going to a maximum of 0.5. So still an object that's fairly plasticky, but it's less reflective than the previous render because we have less of a reflection amount. And now what if we took that reflection amount of 0.5 and a Fresnel influence of 0.5? What's that going to give us? Well, it means that we have a reflection amount maximum of 0.5, and then we have Fresnel telling us where we have the glancing angles, we have more reflections, where we have facing straight on angles, we have less reflections, but we're only going to take 50% of that calculation into account. That means that where we have dark areas in our Fresnel calculations, they're only going to be affecting our reflection amount 50%. They're not going to be able to drop it all the way to 0. They're going to only be able to drop it down to 0.25. So if we were to render, and wait for this to render, fantastic, and jump back and take a look at this, we'll now see that our high points, our highlights are going to be the same because that's where we're getting 100% reflections from Fresnel anyway, but all of the other areas that were being affected by Fresnel are now affected far less than they were before. The result is an object that looks kind of plasticky, but it's closer to metal than we had before because we have less influence in terms of Fresnel. So the last thing I'd like to test is just to switch over to using a texture, and I want to use the black and white checkerboard texture to control our Fresnel influence. And that should mean that in the areas of this texture where it's white, we have 100% influence with our Fresnel, but in the areas of the texture that are black, we have 0% influence with our Fresnel, which should mean we get a reflection amount of 0.5. So let's go ahead and re-render this one last time. Let's take a look at mantra. There we go. Fantastic. And let's take a look at what this looks like. So there we go. We are getting a reflection amount coming back. And I believe, did I set the reflection amount to 0.5 and then the Fresnel influence to use texture? Exactly, there we go. So what we're actually seeing is a little complicated because of 0.5. But what we're actually seeing is these areas where the texture was originally black is outputting our 0.5 reflection amount value no matter what. This is the area where the texture would have originally been white, which means we're outputting our Fresnel based calculations, which is giving us that fall off based on Fresnel. It's a little hard to see, and I actually got thrown by the fact that obviously the result we're seeing here is kind of the inverse of what the texture is actually doing. The brighter areas, the lighter areas are really where that texture is black, and the darker areas are where that texture is white, giving us full Fresnel influence, which is obviously dropping our reflections way off, way down. And you can see that this is indeed based on glancing angles having a stronger influence, and again here, so our viewing angles taking effect, whereas in these brighter patches where we're having no Fresnel influence because the texture driving them is black, you can see that we are indeed getting just our 0.5 reflection amount. And if we were to look at what that looks like in our blend, it's going to look pretty crazy, but we do have now a lot of control over our reflections and how the reflections balance with the diffuse, because we now have the ability to specify a reflection amount as a value or a texture and to scale that texture. We can also specify an index of refraction and how much influence Fresnel calculations based on that index of refraction have. and we can take all of that, and that determines how we blend back and forth between reflections and diffuse. And with that, that's going to conclude our diffuse reflection balance pass, which in turn is going to conclude all of our render passes, and it's also going to conclude, if we take a look, there we go, take a look at our material, it's also going to conclude the surface shader portion of the material. All that's left to take a look at, and it will be a very brief look into this, is going to be displacement. But in terms of the surface shader, in terms of how we're working out our reflections, our diffuse, and how we're blending back and forth between them, all of our work here is now done. All that we have left to look at, and that's what we're going to be looking at in the next couple of videos, is displacement. So with that, that is going to conclude this video. Thanks a lot, everyone.